Thank you so much for joining after lunch. So if you are still processing your food, if you haven't got a coffee yet, maybe I would recommend you to go and get one. This is a 50-minute sessions about cloud native developer experience in 2025. I will be covering a bunch of different topics, a bunch of different tools. And this is the first time that I do this presentation, so it might look a little bit improvised. I have 8 different demos that can go wrong, and I will just run them here live. I have some videos just in case that everything goes completely wrong. But let's see how that goes. So the title is Cloud Native Developer Experience, but in general terms, what I'm talking about is that why are we wasting so much time? When we work with cloud native technologies, we tend to overcomplicate developers and their tasks, and we want to make that better. So my name is Mauricio Salatino. I'm at Salabo in Twitter and Blue Sky, and I'm ecosystem engineering at a company called Diagrid. This is a small startup working on this CNCF project that is called Dapper. I'm also a cloud native ambassador and a Java champion this year, and I used to do, when I was younger, this session with this badge, which is probably coming from Twin Peaks, a series from the 90s, that says, "Fire, walk with me," which is kind of like how I feel when I run live demos that can break, and they are a little bit more complicated than the usual. For me, being here, it's extremely important. This is the 10-year anniversary of this conference, counting JVCN that was done before. It started in 2015, but I've been involved in the Barcelona meetups since 2012. So for the last 10 years, since the conference started officially, I've been doing sessions here, so you might have seen me doing some of the sessions in previous years. The earliest tweet that I can see that it's related to the Barcelona Java user group is in 2012, where I presented one of the books that I wrote at that time about a Java framework. And then since then, I just been doing more cloud native presentations. I remember in 2015, the first year that JVCN Conf was done, one of the keynotes was titled Kubernetes for Java Developers. At that point, I've been using Kubernetes for maybe 4 months and doing heavily containers for at least a year. And I remember when I saw that presentation that something changed. I was working at the company, and when I came back from this conference, I actually quit my job, and I said, I need to go and work on Kubernetes. Because my experience so far was OK, this is extremely complicated for developers, and there will be a lot of opportunities to help developers to improve their speed. If you move 10 years into the future, we are still working on making developers efficient on top of Kubernetes, and I think that there are tons of things that we should do. I wrote a book about Kubernetes in 2023. It was published, printed in a physical version, but I started in 2021. It's all about platform engineering on Kubernetes, or another way to put it is you learn Kubernetes, but then you need to learn a bunch of other things. So this is all about tools and practices that kind of make sense when you are working in a company that is using Kubernetes as the main deployment platforms for your applications. It's very infrastructure focused. But because I'm more like a Java developer and Go developer, the book has that developer-centric view of the world, of which kind of tools I'm interested to use. And of course, in the process, I made a lot of friends. When you write a book about open source projects, and in this case, it's a book about 25 different open source projects combined together, you met a lot of friends, and I realized that I was presenting in the same conferences and the same spaces of a very good friend of mine whose name is Thomas Vitale, who also wrote another book mostly focused on Java and Kubernetes. This is more about if you're a Spring user, how do you use Spring into Kubernetes, and the tools that you need to be efficient on top of that. And that led us to become friends and do a lot of presentations together. And last year in November, we signed another contract for writing a book titled Developer Experience on Kubernetes. Because we have been working in that space for 5 years, we thought, OK, we have enough examples. We know a lot of the maintainers of the tools that I will be presenting here, so it might be good just to put everything together in a book and try to raise a little bit awareness of the things that we see in that space. The book is divided into 3 different parts. The first one is, let's explain Kubernetes people what developers do. I think that's the first part, the first 3 chapters, which is what do developers do, what do they care about, the tools that they use, and the tasks that they perform. And then what happens when you add Kubernetes into the tasks that developers are doing. The second part is about cloud-native runtimes, and this is all about that, something related to platform engineering in the sense of you have Kubernetes, but you have a lot of tools on top of Kubernetes. How does that affect the developer experience and the services that they have available in these runtimes? And the final part is a little bit more about the outer loop. How do we improve all the things that developers do not see, like all the pipelines and all the data that is generated, for example, in production environments, and how do we bring that back to developers so they can iterate faster? So the first part of the book, again, as I mentioned before, it's like teaching platform engineers. You need to learn about what developers do. And we have recognized what we're trying to do, because we are actually writing this book right now. Like, it's in early access. You can access the book, but we have written like 4 or 5 chapters so far. You can access the draft for all these chapters. But what we are trying to do there is just try to identify patterns, and patterns based on the challenges that we see different teams experiencing, right? So we are calling those like friction points. And then we basically analyze the industry, the open source tools that are available to solve or mitigate some of these friction points. And of course, also explaining developers, on the other hand, what happens when like a platform team or like a company push them to use Kubernetes on day-to-day basis. So kind of like introduction, if you are developers, like we have all developers here, like in the room, yeah? Yeah, we have a lot of developers, that's it, yeah. So I don't need to explain you this, but like that's kind of like what we explain. Okay, platform teams, this is kind of like how we're going to divide things. You get requirements, you have like the inner loop, which is including all the tasks that developer execute, and the outer loop is everything that happens after the code is pushed to a repository, right? Like to a version control system. And then at some point in time, we have that in front of customers, and the amount of time that it takes to, from the developer, like making changes, pushing that to it's in face of the customer, it's kind of like super important. That's kind of like our speed of delivering software. So I think that we just need to focus on improving that as much as we can, making sure that we don't make the life of developers more complicated. So when we look at the inner loop, we are trying to, again, just keep it super simple. You have requirements, and then you have like coding, testing, running applications, debugging, normal stuff that developers do. They will just push that into a source version control at the end. The outer loop is all the things that happens after. Again, super simplified. You just commit that, and then you trigger some pipelines. You will do acceptance testing, end-to-end testing, integration testing, performance testing in an environment that is closer to production. And this is where we start thinking about, like, OK, we are writing code that developers are running in their laptop, but then we are running the same code in environments that are completely different from what the developer is using to create these applications. So here, kind of like the optimization, it's more about that. How can we shift left and bring developers closer to the tools that are being used in these environments, so we can just reduce the changes that we need to test when we do this outer loop side of things. So as I mentioned before, we looked into the inner loop and the outer loop, and we have identified like 10 friction points that developers will face when doing their tasks, but also the friction points that will affect developers' performance on the outer loop, the things that they cannot control. Right? For this presentation, and again, because we started writing the book from chapter 1 onwards, not the other way around, we are going to be discussing a little bit about that. Again, this is a developer conference, not so much like an infra conference. So I will start looking into these first topics. Right? Like, I'm not going to cover what happens when you want to bootstrap a new project from scratch. But definitely we'll be talking about development environments, then what happens when we are making changes, testing changes, and running changes. Because all these things can mean completely different things if you work in a bank, if you work in a hospital, or if you work in a startup. Right? Completely different things, completely different tech stacks. Very important, as I mentioned before, Thomas is a Java developer. I'm more like on the cloud native space, also with a heavy Java background. But we are trying to make all the examples and looking at the tools that are polyglot, right? Like they implement some sort of pattern that can be used across different programming languages. So in order to mitigate the friction points, what we are trying to do, again, is we are trying to formalize patterns that can be explained no matter the tool that you're using. But if you are like building developer experience inside your companies, you can look at the patterns and say, OK, I'm not using tool X, but I'm implementing the pattern, so I'm moving towards a better developer experience. The first that I want to discuss is called development environment activation. And this is all about how do we set up developers for success instead of making their life more complicated. The second one and the third one are a little bit more related of, if we want to run our applications on top of Kubernetes, we will need to deal with container images. And then if we run our applications in Kubernetes, then we will need to have some sort of way to sync what the developer is doing and what the cluster is like deploying there, right? So the first part of understanding development environments is to kind of like, first of all, like in order to understand what the developer environment is, we needed to, again, like try to codify in a way that we can explain different teams working with different tech stacks, like the different building blocks that a development environment will have. Very simple stuff. Version control system, you are versioning your source code. It's very difficult, like if you don't do that. Then the language runtime pack is basically kind of like what kind of stack are you using? What programming language and what does that programming language requires? You can see the examples here is like Java with Gradle, like the package manager for Java. Then Go and Go modules probably. If you're using Go nowadays, you use Go modules. And then Node and Yarn are like common combinations that we see people using in the industry. Then you go up, like the container runtime. This is developers nowadays, I think that like they know what containers are and they are using containers for certain things, which I think is great. So we are taking that like as a fundamental part of modern developer environments that can simplify a lot of the setup, configuration, and usage of like third-party tools. And finally, depending on the community, you will be having kind of like code editors. Nowadays, Cursor is pretty wild. It's pretty like everywhere. But other IDEs are also valid. So we are looking also a little bit into that space. For the book and for this presentation, I think that we can like try to reduce a little bit the scope and say, let's cover, like let's make sure that at least we have like Java examples, Go examples. We chose Git because why would we choose something different? If you're using something different than Git, you can probably map all the concepts in the same way. And then for the container runtime, we chose Podman, which is, how many people here know about Podman? OK, we have like a fair amount of people here, right? So Podman is very similar to Docker, following kind of like the OCI standard implementation, standard interface, container interface for providing a container runtime. We chose Podman for different reasons, because Docker did some crazy things before. We have friends at Docker and Red Hat, which is one of the main companies behind Podman. But I think that Podman, kind of like the Podman team has a better understanding on how to build experiences that are across containers, developers that have like a stack, like a programming stack, like Python developers, Java developers, and on the other hand, they have a deep understanding about Kubernetes. So they can create like an end-to-end experience for Kubernetes-based scenarios. And that's the main reason why we chose that. And then IntelliJ and VS Code as just an examples, like IDEs that you can use. So I mentioned before Podman, and the reason why we believe that this is fundamental for developers to have a container runtime in their development environments is because like if you want to install a database, you are not going to install PostgreSQL manually into your laptop. Because first of all, that will probably go outdated quite fast. Also because it will just take you some manual step to install. With Docker, you can just run a PostgreSQL instance locally for development purposes. The same with Redis, the same with RabbitMQ, the same with Kafka. Again, we talk to a lot of different companies. We see a lot of people doing this. We consider this kind of like part of like a modern development environment. So we said, OK, this is a fundamental piece. You need to choose one container runtime and then just go with it. So let's talk about the first pattern that I mentioned. The first pattern is called development environment activation. The idea is you have a development environment definition on one hand. It doesn't matter how do you define it. It's probably good to have it like in a declarative way, where you don't say, install these things after the other, but more like, I need an environment with these 10 tools, right? And then you run something, or you do something called activate, and then you have like a development environment for you to work, right? The idea here is, again, is like avoid that idea of, I have this wiki page that tells me these 20 steps and things that I need to run in order to install all these tools together. That goes out of date pretty fast, but also it's just prone to mistakes. So we want to automate that in a way. Related to this topic, there was a presentation here in Barcelona at the conference called Spring I/O that it's all about like cloud development environments. These are like remote IDEs and development environments that you can run in the cloud. Very close to this topic, but this is not what I'm talking about here, right? Like this is setting up a development environment in your workstation, in your laptop. And for that, I'm going to be talking about two different things. We can call them tools. We can call them different things. But like dev containers. How many people here knows about dev containers? OK. Not everyone, so that's good. And how about like Nix and Flux? We have one. That's the person who shouldn't be in this room, but thank you so much for joining. That's very good. And I think that that's exactly good. So if you take one thing away from this presentation, Nix, unfortunately. And again, I feel very uncomfortable saying this because First, I didn't understand what it was, and then I thought, why do I need this? Let's go through dev containers first. So dev containers is a specification that was created originally by Microsoft. Now it's part of something else, I think, like a foundation or something. But the idea here is, again, you have a JSON file to define what a development environment is and the tools that you are going to install in that development environment and the configurations that you need there. It's language independent, and it's adopted by a bunch of different tools like IntelliJ, VS Code, and even GitHub code spaces. The idea here, again, is I define my development environment, and that basically means that when the developer wants to start working with this source code, they have all the tools that they need in the right versions. So let's look at how that works. The idea is I define this in a file called devcontainers.json. I open my IDE, and the IDE recognizes that my project has a development environment definition, that it can activate, and then I can have my development environment. The important side of these dev containers is that it's heavily based on containers. That basically means that the development environment on itself will be a container that it's running on top of your container runtime. In this case, Podman. We're running it with Podman. And you can see here that basically when you do activate, you get a container with the version control system or like connected to the version control system, a language runtime pack that might be Java, Python, Node, or whatever you want. You have access to the container runtime to start other containers, and then you have a code editor that is connected with all of these. But because it's a container, then you need to make sure that maybe you need to mount something from the file system, the source code maybe, or some files that you need to mount. And then, because it's a container, you need to make sure that you expose whatever endpoint, the things that you are doing inside that container are needed to be accessed from the host machine. Let's see that in action. I think I have two demos here. I wanted to show you dev containers for both for Java and Go, which are the examples that are in the book. I will share the URL of the repository at the end of the presentation. So I have a lot of demos showing different tools, and that's why I have some sort of like a script where I can copy stuff, because I'm getting old and I cannot keep like 8 demos in my head. This is kind of crazy, but OK, let's do it first for Go. So this is kind of like being covered in chapter 2, and basically there are some exercises that you see like the end there, and this is the Go example, right? So I have a service that it's called appointments, and what I want to do here is I want to open VS Code, right? So I'm opening VS Code on a Go project, right? And when VS Code opens, fingers crossed, it will show me this. It says like reopening container, right? So I will click there, and you will see that like VS Code is kind of like restarting, and now I don't know if you see it back there, but like let me see if I can. You see here, like on top, it says appointments devcontainers.go, right? If I go to Podman, let me go here to Podman, I can show you the running containers, and you will see that there is something here that's called friendly Kayam, I guess, which is my instance of my development environment inside the container. So this is VS Code connecting to a container that has all the tools that I need to work on this appointment service. How is that configured, you might wonder? And that's using this file that I mentioned before. Yeah, sure. Get my data. OK, so this is kind of like pretty much the devcontainers.json file that you can add to any project that you want, but basically defining what the development environment needs. This is the Go development environment. It's using this base image. In real life, you probably will have a different image that is like your company producing. And then you have this section that is basically called features. Let me zoom in there. So features, you see, first line, well, let's install Go, right? You can actually go and define the version of the Go runtime that you need. The second line here, apt packages. This is using apt-get from the Linux, community to install different packages. In this case, I'm installing a tool that is called HTTP-Py, which is kind of nice for sending HTTP requests. And finally, I'm configuring something else, which is Docker outside Docker. We'll leave that for later, but have an idea that like if you're running stuff, you need to access to the container runtime just to start other containers. So that's kind of like what gives you that. And finally, it has this customization section. In this case, I'm customizing VS Code to have some extensions, right? A bunch of like extensions to read YAML, and the one that I wanted to show here is like the PostgreSQL extension here, because I have a service that uses PostgreSQL. So I wanted to have something to do queries to SQL, to Postgres in this case. And you can see that this instance of my dev container has like the extension installed, right? So if I have a database running, I can connect to it and do queries, just to see that my application is doing what it's supposed to be doing. So next step, and I will just check the README here. next step is just to use Podman Compose, because I'm running a Go application that needs a database, so I'm going to start the container with PostgreSQL, right? You see here, it's just starting one container, same as doing Docker Compose. This is Podman, so it's called Podman Compose. Done. So that's running the application, and then the next thing that I will do is that I do go run appointments.go. That's my application. And you can see that, again, I don't need it to install anything, and the development environment here is like, hey, you are running an application that is running on this port. So I'm going to suggest you to open the browser to see what's there, right? So now, not only I've started the development environment, I'm running my application inside that development environment with the Go version that I need to use for that application. But I also have automatically exposed some ports. So as a developer, I can see what my application is doing from outside the container, right? So it's trying to automate the entire activation of the development environment so you can start working right away with the source code. Nice thing about Dev Containers, again, is that it's integrated with GitHub code spaces. So if you add this file into your GitHub repository, you can actually open a cloud a cloud IDE that works in the cloud, and you don't need to even install VS Code in this case, which is kind of nice. I'm not a big fan of cloud development environments like remote IDEs running in the cloud, but they are getting better and better, so that's definitely something that companies will do at some point. So this is kind of like what I have running here. And I think that I can just send a request here. I'm using HTTP, as I mentioned before, just to send a request, just to make sure that the service is working and it's connecting to the database, right? So this is actually connecting to the database, generating an ID, and storing that. And of course, I needed to run that because I wanted to show you that I can connect to the database here. I changed this configuration. I shouldn't have changed that, but I need to do this Postgres, so the user is Postgres. Again, this is the default configuration for the Docker container for PostgreSQL. So if I connect that, you see that automatically it connects to my instance, and I can select the instance that I've just created by sending the request, right? So that's pretty much the same thing that I have here. Again, a fully functional environment. This gets complicated the more tools you have, and the more tools that you have that are internal to your company. But again, because it's Docker, you can package in containers pretty much everything. You can create a base image with all the tools, and there you go. You don't need to configure much else. So that's the first example. I can see that I'm going to run way over time, so I will just speed it up. I had the same thing for Java. How many Java developers do we have here? All of them. Do you want to see it for Java, or you kind of like get the idea? I've started a development environment for Go. I guess that you will just expect the same thing for Java, right? It's just the same thing. What I can do is I can, if you notice, I don't know if you noticed, but I close the IDE. So at some point, like the containers will be cleaned up, right? Like the container for running VS Code itself is already gone. I run Docker Compose inside, and this will be cleaned up at some point when it detects that they are no longer needed. So that's one thing. I can show you the Java side of things as well. You will see me doing a lot of this going back to the root, so I can just copy the commands from here. I don't want to spend too much time, but it's pretty much the same. With the only difference that in Java, it's much more common to use something like test containers to run containers instead of Docker Compose, right? And I just wanted to show that it's pretty much the same experience. Instead that we can just run test containers in the normal way, right? So reopening container. The dev containers JSON file, it's just pretty much the same as the other one. But in this case, instead of installing Go, it's installing kind of like the Java runtime. You do it with this. Dev containers have a lot of extensions. You can create your own, and you can define versions, configurations for that specific package and everything else. Similar, same plugins, same things. The only difference here is that because I'm starting with test containers, my application, I don't need to run Docker Compose or Podman Compose or anything like that. I can just go and do something like this, Gradle run, Gradle boot run, and this is just going to run my application, right? Big difference here, again, because when we are using test containers, there you go. It's back. Again, Gradle run, opening in the browser, same as before. It's recognizing that I have something like that. It's defined there in the configuration as well. So I have the application running. I can send requests. Big difference, and that's why I changed my PostgreSQL configuration, is now because I'm starting this with test containers, is starting the container in random port and with different credentials because it's a different configuration coming from test containers. So I can just not connect to that instance, right? Like I can just not do a new query there. I think because, I can just not select anything from here because Or maybe I do, I don't know. This is still connected to the previous. That's tricky, you see? That's tricky. That's something that we need to fix in the example, just to make sure that that doesn't happen. But this is not the same instance that I'm running now with test containers. The test containers instance here is probably in a different port. So if I want to check that database, I need to do podman ps maybe, just to find out in which, let's see. I need to find the port. Again, it's a randomly generated port to connect to an instance, so I will just need to change the configuration manually here. There are ways of automating that. It's not super straightforward so far. There are some extensions being written right now. So imagine how would you change the port. It's not that difficult. One more thing that I want to show you here that I think it's important is that if you look into the Gradle file for defining the dependencies here, I'm not defining any PostgreSQL configuration, but we are looking into promoting some of these things for testing services, right? So what we have done here is we think that when developers are using these kind of things, like depending on infrastructure, like in this case, a PostgreSQL database, it might be better to create libraries so developers don't even need to think about how do I connect to a PostgreSQL database. In Java, it's quite common to use something like H2 for in-memory databases. And what we used to do is we just add H2 to our class path that will have all the configurations. So Spring Data will connect to that automatically. So we are doing kind of like pretty much the same here, is having a library that basically defines how do we connect to Postgres, so developers don't even need to wire all the things together. And that's pretty much solved here in a library that you can find here. And again, this is like a very simple example, but I think that it proves the point that if you're trying to help developers as like a centralized teams that build developer experiences, these are one of the things that we see a lot of people thinking about. Some of them are doing them. Some of them are already kind of like trying to implement these. And you see the only thing here is that we are using test containers and all the latest and greatest Spring Boot integrations to just get the container started and stopped whenever we are starting our application, and then getting the connection details using the service connection annotation. This is doing a lot of magic that we don't need to expose to developers. They will just change this and they will get confused. So let's just try to hide that away in a library that they can add to the class path, and that's pretty much it. So let me stop the application here. I just don't want to keep like containers running all over the place, because if not, the demos, then the following up demos, they will start getting more complicated. And that's why things start failing. So let me see here. So we have a lot of stuff. I will stop these ones because I'm pretty sure that they will clean up at some point. But if they are not getting cleaned up, that basically means that something is still using them. And that's it. I don't have more containers. So let's go back to the presentation. So that's dev containers. And as I mentioned before, dev containers is nice. Don't get me wrong. They have made a good progress on that. But running development environment inside containers, they have some drawbacks. We are running now inside containers. So all the limitations that a container will have, we will just start hitting when we're building our development environments. First of all, it's running in a separate context. It's not running in your host machine. So you need to connect and make sure that you move all the files there, or at least mount all the files there. There might be permissions issues, credential things that you have only on the host machine that you don't want to move to the container, or it's not easy to move. It might become a problem as well. And all the networking side of things of containers might become complicated. The idea here is we should automate everything. We shouldn't expose any of that to developers. So again, containers become a little bit more complicated. And when you start working with Kubernetes, starting or connecting to a Kubernetes cluster from a container is not impossible. There are tools to do that, but you need to be careful. And that takes me straight to Nix OS, which is a different approach. We are not using containers. We are using something that is called Nix. Again, I wasn't a big fan at first because I think that I didn't understand it. And I had that like Linux feeling. I'm an old Linux user. I started using Linux like in 2010 or something. But I remember when I started using Linux, I started wondering, why all this complexity? Why it needs to be that complicated? And there are reasons to be complicated, of course. So NixOS is let's think about NixOS as a package manager, right? But each package is being built to be fully reproducible. That basically means that all the dependencies are built from source, and you are keeping track of the exact commits that have been used all the way up to the chain, right? And you can imagine, like you have a package for doing X, but that depends on Y and another package. So now you need to make sure that you are depending on the right version based on a commit and a hash. That's super high-level explanation of what this does. But it's being built just to create super reproducible packages that you can install quickly in your environments, right? And again, this is very low level. How do you create the packages? How do you package them? How do you distribute them? It's kind of like low level for the normal developer. And that's why other companies are building kind of like UX or like user interfaces on top of Nix, right? Like using Nix as the underlying technology. Think about like low-level kernel stuff on the Nix side of things, and this is kind of like user interface. How do a developer will use this? So this is called Flux, which is pretty much like a layer on top of Nix to make it easy for developers to use. An integrated software fabric for teams. That's a very complicated way of saying this is like a package manager, like much more like user-friendly, right? And I don't know if you see here on the side, but basically the idea is you go into a project like I did with dev containers, you run Flux activate, and that will set up the development environment using Nix packages for you. So you guarantee that whatever is inside that development environment has exactly the right versions with all the dependencies of those versions. And what it's showing here is that, OK, you are in an environment, and you're running Node version, and you know that you're using the right Node version. And now this is being built for every language, every technology stack, right? And more importantly, every architecture, right? So I don't know, like if you're using Macs, but when we switched to M1s and ARM64, it was a bit complicated. Like we didn't have the same package managers, the same packages available across multiple architectures, and this is built from the ground up to be multi-architecture. I think that that's pretty important for covering use cases in companies where they have like Windows, they have Linux, they have like Mac OS, they have like old machines or different architectures. So super important. Let me show you how that works quickly, because again, I'm just running out of time. So we will go back to the root, and then we will just follow kind of like the instructions here. I will show you this one, right? So we're going to chapter 2. This is a Go application, the same that we looked at before, the appointment service. And then what I do is as I mentioned before, Flux activate. And the first time that you run this, it's actually going to fetch all the packages and create those configurations. Now everything is set up, like it's already cached, so I don't need to run it again. And what you can do here inside Flux is pretty much do something like this. You can do type Go, which tell me like which version of Go I'm using. And you can see here like kind of important, like Nix is based on the file system, right? Like remember that dev containers was based on containers, on creating containers with tools installed inside containers. This is pretty much using a file system structure to make sure that the tools that are being used and included in the path are coming from the file system, in this case, specific to this project. You can see that I'm using a Go version that comes from that architecture, which is the architecture that I'm using. But the most important part here is looking into the configuration. And you will see that this is a super simple configuration. So the configuration basically says your development environment, let me reload the window, your development environment will include Go. That's how you define Go and the name of the binary that you're going to use, HTTP/PY, and then we are just going to install some VS Code extensions. Super important, down here, the architectures that this environment supports, right? Like all the packages, if you're running in a different architecture, you're going to get the same versions of the same packages being built with the Nix ecosystem. Nix ecosystem is one of the largest ecosystems hosting, I don't know, like a crazy amount of packages, so you should definitely check it out. I can do the same here as I did before. I can do like, Podman compose app, go run my appointments. The only thing that will change in this case is that I'm controlling the version of all the binaries that I'm using for building the environment using Flux. The same for Java. Java looks exactly the same. Instead of installing Go, we are installing Java. The same tools, I think, that are pretty much the same. We do a lot of other tests to show kind of like the advantages for Flux in the book. For now, I think that I will just keep it short because we are totally getting out of time. So let's go back here. Again, if you take one thing, it's just check this. I think that this is the way, definitely the way to go. It feels like this is the right solution for the problem that we are trying to solve here. Same thing, as I mentioned before, you define the manifest TOML file. Why TOML? Don't ask me. I wouldn't choose that. But like again, you define it somewhere declaratively, and then you just run Flux activate, and you get a new development environment with all the tools set up. You can set even environment variables in there, just things that you need in there, all coming and using packages from the Nix store, and you don't have the problem that you're running in a container now. You're running in a place that have access to all the host information, but you have like full control on how to automatically configure the things that you need for the development environment, which I think is pretty cool. So that's the Flux demo. And then let's talk about Kubernetes in the last 15 minutes that I have here for the presentation. When you add Kubernetes into the mix, the things that I've been showing you is like you start the project, you start some containers that the project needs, and then you start using it or changing it. When you start using Kubernetes, things becomes extremely complicated. You now need to containerize your application just to deploy it on the cluster. You need to distribute that container image so the cluster has access to it. And then you need to create the YAML files for Kubernetes to understand how to deploy your application. Finally, applying the manifest to a cluster that you need to be connected to. So for me, I always ask like companies, do you really want to give Kubernetes to developers? And it's half and half, I would say. Like half would prefer to do that because they can train their developers, but also because that will reduce the amount of time and differences between environments, which I think it's a valid concern. But the amount of stuff that we are doing here and pushing developers to do, it's quite crazy. And then the question of, OK, where is your Kubernetes cluster that you want to deploy to? Is it like inside the development environment? Is it external? Who creates the instance of the cluster? How do I connect to it? Where do I get the credentials? And all of those are questions that the developer shouldn't be in charge of answering, right? So in order to start discussing the Kubernetes side of things, as I mentioned before, we have a pattern called source to image. It's funny, there is a tool that it's called like that from Red Hat, but the pattern, again, it doesn't make any reference to any tool, a specific tool. And the idea here is you have source code from your application. You want to have a container image, and you don't want to use Docker files. There are tons of reasons for not using Docker files. And there is a very funny article called 9 Common Docker File Mistakes that it's linked there, which basically take you through all the things that can go wrong when you create a Docker file. Docker files are kind of like the best thing that Docker did, and probably also the worst thing that they did. It's pretty easy to write one. It's very difficult to write one for production. So you need to be super, super careful. Pushing developers to have the responsibility of defining how they are containerizing an application might not be the right use of their time, again, because they need to become experts on how to do this for production scenarios. So some companies do this, some companies try to use other tools. And the objective of the book is to show you the tools that you can use to avoid doing this. And for that, I wanted to show you 2 different tools, and I think that I would just do that and finish the presentation there. But like, we have Go from Go developers, and then we have build packs, which is a little bit generic for multiple languages. I wanted to show both because, again, if you're a Java developer, you probably haven't seen Go. And if you are like a Java developer, you're probably already using build packs, so I will just keep it short there. So let's do that. I'm already exited here. Let me check my containers. No containers running. So when you're using Go, the idea here is that you don't define a Docker file. And you can create a container image from your Go application by just running a simple command. So let's do that. Why? Why am I still trying to type? There you go. So let's do that. And the idea here is, again, I'm going to use Flux for activating my environment. Because I'm using a tool. In this case, this tool is called Go. And it's coming from, it's like a Go tool for building containers. And what I can do here is probably show you that there is no Docker file in the directory. There's no Docker file here to containerize the application. So Go understands that I'm building a Go application, and it follows the Go standard definition of how an application should look like. You can parameterize it if you want to. But I'm running this command here, go build. Let me zoom that in. It's go build local platform all, and then the tag for the container image, right? And I wanted to show you a couple of things that will happen here when I run this. It's pretty fast. That's because Go applications are super small. But you can see 2 things, important things. Like it's picking up a very, let's say, secure, safeguarded base image for my container, right? So I'm not putting the developer in charge of defining what's the base image for my container. This is just defaulting to one that it's being curated by a company that does that for living, right? The second thing is understanding that this is on a GitHub repository. So it's going to check that I do not have uncommitted files. So if I'm creating a container, I want to make sure that I point to a commit SHA into the container image, right? To make sure that I keep track of all the things that are being included in that. So basically, it's complaining. It says, like, you have local changes. Don't do that. I'm just doing it now again. Doesn't matter. But it's pushing you to kind of like implement best practices there. And then it's building the container for multiple architectures. You can define which architectures you want to define. And then it's going to try, like, I didn't instruct it to do this, but like it's going to try to publish these container images into a repository. In this case, it's using a local repository in my machine just to distribute that. And finally, I will have a container here with the SHA stored in my local repository that I can run, right? So that's the whole point. Podman run, right? So I can just run this container. It's going to fail. It doesn't have a PostgreSQL running here, so of course it's going to fail, but it's been packaged. Interesting, Go developers. Go developers, and this is coming kind of like in the next pattern, but like Go developers will not have any live reload of the application, right? Like when you run like the application, you are not expecting to change the source code and then see the changes in the application. You are just going to stop the application and start it again, right? And that's kind of like an interesting way. So if you are creating containers, developers will expect the same behavior, right? Like they will just do build again and then just get the new image. That's why this process needs to be super fast, because they will want to start that container like in a second or so. So that's the core side of things. It's extremely easy to use this because, again, it has automated not only the build, but the multi-architecture, the detection of the project, no Docker file needed, and then the pushing and distributing container images so they can be used by a Kubernetes cluster or by other teams. On the Java side of things, I have 9 minutes. On the Java side of things, I want to talk a little bit about something that is called build packs. I didn't show you this for the other tools. Let me do this again. So I was talking a little bit about Co. That's the website for the Co project. If you're interested, I strongly recommend you to look into this. When I use Spring, I would love to have that experience. For Spring, we don't have that. It's different. But we have build packs in Spring, right? So build packs, again, is what does it say? Cloud-native build packs transform your application source code into images that can run on any cloud. It creates containers from any application, any language. And it has kind of like something interesting that I find super interesting is that it will detect your application, technology stack, and based on that, it will create a container image for that application. You don't need to define a Docker file. It will just do it for you. So if we go back, chapter 3, we'll go back to the Java. Now let's go back to Java. So now I'm in a Java application. I will just activate my Flux environment for the Java application. Then I can do, type Java. You see that Java is coming from the Flux, environment, not from my path, right? Like, so if I go to this one, that it's not Flux, I will do Java version, and I have Java 21. But for my environment, if I do Java version, I will have Java 24. So that's completely automated for me as a developer. Now, with build packs, what you have is you have like a CLI, pretty much that does something similar to what Co is doing, but for any application, any language, right? In this case, I have a Java application. It's a Spring Boot application, so I can do something like this. Pack build appointments, that's the name of the application that I'm trying to build, and then the version. When I run this, a lot of things will happen. So first of all, the Pack CLI, it's going to detect my application stack. And then it's going to start downloading kind of like some container images that contains all the tools to build this stack. And then it's going to use those tools to build the stack just to build a container image for my application. It's doing a lot of other things as well here, but it's pretty fast in terms of building containers. So you can see here, it's doing this. It uses kind of like same as I mentioned before with Flux. It uses kind of like some sort of like packages to distribute tools for building a specific stack. So if you have your own stack and your own way of building your node application, let's say, you can actually create new packages that will be used. And you can see here I have like the container created, and it's still local, right? So I can do podman run, same as before. It's going to start, but it's going to fail due. It doesn't have like a PostgreSQL running there. If I start the PostgreSQL, it will connect to it. So that's kind of like what pack. But more importantly, I think that for Java folks, what you need to understand is that you're probably, if you're using a Spring Boot, you're probably already using build packs because when you run, like, for example, this one, Gradle boot build image, is actually using the same tool. Instead of using the CLI, it's using the APIs and some Maven plugins just to call the same thing that I've just called before. So first it's going to build the project, but then it's going to start using build packs. You can see here pretty much the same output, the same tools from Paketo, in this case, the packages to build this stack are being downloaded and used to create the container, right? So if you're using Spring Boot and Gradle or Maven, it's already integrated with your ecosystem. This is pretty good. And I think it's pretty good because, again, it will allow, for example, platform teams or security teams to go and rebase your images. Let's say that you have like a vulnerability in the base image of your application. With build packs, containers are created in a way that like layers are very well defined. So you can go and rebase an entire layer without changing your application code or without creating the entire container. And that's pretty cool. I think that that's a pretty cool feature to take into account, because that's a real use case scenario that most companies will go through. So I have 4 minutes, and I wanted to mention one more thing, which is the third pattern. I don't know if I will have enough time to show it, but let's see. So that's source to image with build packs and with pack and with co as well. So again, different ecosystem will have different tools. I like the tools that apply to multiple ecosystems, so build packs is kind of OK. It has some challenges, but I think that it's pretty good in principles. You need to go and research a little bit more if you want to actually use that. The third pattern that I want to mention, I will not be able to cover all this in full, but the idea is that if you're working on an application, right, like, and you're making changes, now that you need to deploy to Kubernetes, you don't want to stop everything, build a container image, deploy it, load it into a registry, and then just go and apply some more YAML files in order to have that application running in your cluster, right? Like that will take you so much time. And we are actually we have wasted a lot of time on that. So there are tools that are like used to simplify and automate all this development lifecycle. One tool, it's called Tilt. It was acquired by Docker at some point. I don't know what's happening with that tool anymore. But the tool that I want to show you here, it's called Scaffold. This is, again, coming from the cloud native community, multi-language tool. You can use for any stack. You just need to define kind of like what do you need to run when you make changes in your application, so the changes are kind of like propagated to the cluster that is running the applications. There are like different ways of doing that, but let me show you one. I will just skip to that demo, which is the last one, because I believe that that will at least show you 3 patterns end to end. So I'm going here. I'm going back to chapter 3. This is the Java application again, so pretty much the same place. I will do this. I will exit, because you see I was messing it up. Let me go here, and then here. So again, back into the Java application. And what I will do is I will make sure that I close this. Yes, so it's closed. And the next thing that I will do is I will just run this command that it's called scaffold dev port forward, right? And this is the idea, is like I will give you my developers a command that they can run, so they can actually start their applications. It is a Java application, so it will compile the Java application. It will create a container for that Java application automatically. It will deploy it to a cluster that I have running locally, and then it will wait for the container to be ready. And when the container is ready, you can start interacting with the application that it's running on a cluster and start making changes. The moment that you make a change locally, it will actually sync those files to the cluster, which is pretty impressive. You see here, it's basically saying, I've already have an image for that application, and now I'm basically deploying the YAML manifest into my Kubernetes cluster. So I can show you here that I have 2 things, the application running in the cluster and the database, right? The application is still failing because it needed to wait for the database to be ready to be able to connect. And that's why I think it's going to restart a couple of times. But whenever it's ready, a scaffold will say, hey, your application is ready. It's going to show you the application logs. This application is running on the Kubernetes cluster itself. It's not running in my machine anymore. So it can be a remote cluster. It can be a local cluster. In this case, I'm using a local cluster. So the point here is that I can do something like, you see, I'm in the wrong place. But if I go here and I do code, right, so I can open the application into my IDE. The IDE will load this, of course, and it will load all the Java plugins, in this case, that I have available. I will not use dev containers for now. But the thing that I wanted to show you is that, OK, now I have my application, right? And let's make a change, right? So I have this endpoint that we saw before that says basically, welcome to the appointment API at DevBcn. Let's do this. Of course, I cannot type DevBcn. There you go. So let's see if this works. So if I save it here, I should be able to see here. Yeah, you can see, like, Scaffold now is recognizing there are some changes in my file system from the application code. And it's basically syncing those files to the container that it's running inside the cluster, which is pretty impressive. You see here, like, it's already working. And I can do something like HTTP here. 8080. Nope. 8081. Yes. So you see here, like, I'm not running the original version that I had before adding the change. When I changed the code was synced. And it's even interesting to see kind of like the pods, if the pods are running. And you see like this restart happened when I started the application for the first time, but then it's the same container that it's still running, which basically means that Scaffold is syncing files inside of that specific instance of the container and just keeping them in sync for the application developer just to test the changes. We can do that once more, like if you don't trust me, because I didn't show you that before, but I can change that back or maybe add like a 2 or something. And you see that it's pretty fast, like it recognizes the changes pretty fast. It's restart the Spring Boot application pretty fast. And I can do HTTP 8081, and you can see that the changes are running in the cluster, which for me, it's a huge save in time for developers, and also like cognitive load. They don't need to think about those things. So to finish the presentation, because I'm just on time, second part of the book, as I mentioned before, is mostly on what can we do into our Kubernetes clusters to make them better for developers, to have more services. Also, Gen AI, it's coming there into a mix. It's like predictive AI and Gen AI. How do we integrate that into the developer flow? And the final part, it's more about like the outer loop. How do we improve the information that developers can access to do their job better, coming from production, coming from the pipelines, coming from different places. There are tons of things going on in the industry, agentic frameworks, AI, Gen AI. We are trying to look into the industry to create the right patterns so we can explain that in a generic way, not depending on tools, because I think that that's what we will need for the next 2 years. So new friction points will pop up in that diagram that I showed you before that are related to kind of like all the AI agents, LLMs, and stuff that's happening right now. So that's my presentation. Thank you so much. That's the URL for all the examples that you can run in your laptop if you want to. And check the book as well, because it's early access. And we are eager to get feedback about it or opinions or whatever you want to provide. Thank you so much.